And this is just me showing you guys balancing. All right, so we'll go back and forth with these. That's the method I recommend you use, but if you're not there yet, that's okay. And you can do the columns. Like, it's the most important for you to make sure that you are getting them balanced. That's the most important part. I'm getting to work. So I see an H2, so I'm going to start with that H2. Oh, but look, he's already bounced, so that's good to go. And then now I'm going to flip over to my oxygen. So there's this guy, and there's this guy. Hey, what do I do? Well, I just say, hey, this is balanced. Yes. All right, so then I'm going to go to the next one. I'm starting on the left side. I see a 4 and I see a 2. So I'm going to fix the right-hand side. See, because that's why I usually look for a 2 or 3. I don't try to go with the higher ones. So I'm going to start with the 2. So I need to fix this 2 by making it a 2. So now I've got my phosphorus taken care of because I knew I had 4 over there and I just made the 4 over here, so I'm good to go. But now I have how many magnesiums? Not 2. This little guy matters too. I have a total of 6 magnesiums. So I'm going over to the left-hand side and putting a 6 here. I don't put anything in front of the P because understood coefficient of 1. Here's something that has a 2. So here's an interesting situation. I've got a 2, but then over here on this side, I've got a 3. Okay, well, what that means is I'm going to have to fix both of them. So how do you fix both of them? It's kind of like finding a common denominator. You're going to multiply the one that has a 2 by 3, and you're going to multiply the 3 by 2, the 3. Now, notice I'm going to have to deal with my oxygens. That's okay. I'm kind of hoping they fix themselves because, look, my carbons are balanced. So let's see if the oxygens fix themselves. So I had 9 oxygens here. I had 1 oxygen here, so that gave me 10 oxygens. And then over here I have 8, because don't forget that the 2 and the 4 together, that gives us 8. We have 8 oxygens plus 2 oxygens, which gives me 10. So that one is now balanced. All right, so I've got another scenario kind of like this. I got some different things in it. So I've got 3 irons to 1. So I'm going to put a 3 here. Again, I am not doing the back and forth for these because, I mean, not exactly. I know in my head that I'm saving my oxygen to last because it appears in everything and I'm hoping it fixes itself. So my 3s are fixed. So let's do a quick check on my oxygens and see how they're looking. So 4 oxygens plus, and then I've got 1 over here. So that gives me a total of 5 oxygens on the left. And then I have 3 oxygens plus 2 oxygens. Ah, great. It matched. That gives me 5 oxygens. So I'm looking for the 2. There's my 2. But, oh, it's an oxygen, and that appears somewhere else. I am not starting with him. I'm going to start with the iron. So there's my iron. So that means I need a 2 here. And now I'm thinking, oh, well, hang on a second. I've got 2 oxygens. I've got 3 oxygens. That is so not going to work. It's an odd-even situation. So my fixing didn't work. Well, it's okay. Remember, this is the side that's causing the problems because it's odd, that 3. So let's just go ahead and make this side a 2, and I'm going to erase everything. Like if I do something like that, you erase it all. So I'm making that side a 2 because I'm trying to fix this oxygen, not make it odd. So I got 2. Don't forget it's times the 4. So now I have 4 of these guys. And let's see. So right now I have 2 oxygens, and I have 6 oxygens. Could I fix this side? I could. I got a pair. So if I put a 3 here, that'll give me my 6 oxygens. This combustion problem right here, what you want to do, again, is you want to look for that place where, you know, the numbers are uneven. So I usually say look for a 2 or a 3 to start, but you can start at the first spot. You can start with a larger set of numbers if you want to start with like the 12 or the 22. Let's say you want to start with the 22. We can do that. So I've got 2 hydrogens, so I'm going to need 11 right there to get the 22. And then for the carbon, I'm going to need 12 right there. So right now I have 24 oxygen right here. And I have 11 oxygen right here. So that gives me 35 oxygen. And then on this side, I've got 11 oxygen plus some amount, and I want to equal 35. You'll notice I already have like an 11 over here. So I know that that other number is going to need to be 24. Remember, I got a pair of them, so that means I need this number to be 12. So something that came up in the review session I wanted to point out is that you also get the right ratios if you double everything. So if that were a 2, that were a 24, that were a 24, and that were a 22. So that's all doubled. If you add everything up, you're going to still get like the same numbers of everything. See, 2 times 12 is going to give you 24 carbons. And then 2 times 22 is going to give you 44 hydrogens. And see, you got your 22 times 2, that's 44 hydrogens. And then the 2 times 11 would give you 22 oxygens. And then the 24 times 2 would give you 48 oxygens. And then on the right-hand side, the 24 times 2 would give you your 48 oxygen. And then the 22 times the O would give you your 22 oxygen. So you can see that they're all equal on both sides. Which one's right? It's the lowest ratio set. So kind of like if you answer a problem as 4-6 and you get it wrong, it's supposed to be the smallest set of ratios. So it would not be correct to use the doubled version of it, but you can see that they have a common ratio. You can tell that they're all multiples of 2. And that you just have to divide all the numbers by 2. Another thing to say though is you're actually going to be using these coefficients by the end of the chapter. And if you happen to balance something and you were using the doubled version, these red numbers, you would still be able to do the math that uses these ratios if you use the doubled ratios versus the single ratios. But for the way that we write equations, we try to make them as simple as possible, and it's this lower format, not the format with the doubles. The last one right here is combining two ideas. Remember, it says, write the balanced equation for the reaction in which copper metal, remember how we did that before? Cu metal, which is not an M, but a solid, plus oxygen gas. Remember what's special about oxygen? You should have seen it by now. It's diatomic as a gas, and it makes solid copper 1 oxide. So how many coppers do I need? I gotta have 2. And it's solid. Oh, I got this little funny spot on my screen. Now it's saying, hey, go ahead and balance it. Okay. Well, I look for the 2 and I ignore the oxygen. So there's my 2 right there. So I'm going to put the 2 in front. So I got 2 copper, I'm good. Double check my oxygens. Oh, phooey. I'm going to need to fix this because I've got an odd, even situation. So I'm going to erase what I did. I'm going to put a 2 in front of him. So I just made him even. And then now I have a total of 4 coppers.